Hello my dear students, welcome to the class of 11th English medium. The subject is statistics, chapter 3, measures of central tendency, brought to you by Vitan sir. Today we are going to start with the final method for calculation of arithmetic mean, that is continuation of the classified or group data. Continuous frequency distribution. Last time we discussed about the arithmetic mean with row data and then the shortcut method for that, and also the discrete frequency distribution. In this tutorial we are going to discuss about the continuous frequency distribution and some other topics. Okay, so in this kind of distribution, what we need to do, we need to remember that the classes are there and each class has their own frequency. Therefore, the exact variable is not known, rather the classes are there. So we convert those classes into mid values, and the mid value of each class is considered the variable x. In the discrete frequency distribution, we directly have the value of x. In the continuous frequency, we don't have the variable x, we have the class. So we convert those classes into mid values. How to calculate mid value? I hope you guys remember, that is the upper boundary point plus lower boundary point divided by 2. That is the mid value. So mid value of a class is taken as x. Now, taking mid value of each class, a column of variable x is created, and then mean is calculated using the same method as we used in the discrete frequency distribution. Because once we get the column of x, we just have the column of f, and then we continue with our regular work. There will be small difference here, because the classes are there, the class lengths are usually almost equal. Okay, and when the class lengths are equal, we have the common factor of class length between the values. So mostly, in most of the times in the continuous frequency distribution, the shortcut method is used, that is x bar is equal to a plus summation fidi upon summation fi multiplied by c, because it is very easy to get the common factor out of these classes, so it becomes easier to calculate. But in the rarest of the rare cases, when the class are so unequal that we cannot actually calculate a single common factor among them, then we have to revert back to our original formula of fixi divided by fi, or fixi divided by n. But in the maximum number of cases, the left side formula, that is the shortcut formula, is used in the continuous frequency distribution. You will get it once we start with our illustrations. I will start with the first one. Illustration 7. The following data represent monthly income of factory workers. Now we have to find the mean income. Now the table I have prepared here already, it shows income and the number of workers. Of course, number of workers is our frequency. The income is in the classes, that is 2000 to 3000, 3000 to 4000, 4000 to 5000, 5000 to 6, 6 to 7, 7 to 8, 8 to 9. Okay, so as you can see in the classes are all equal. Okay, all of the classes have been equally distributed. So we will use the shortcut method. This is the frequency given in the question. I am just writing down the data here, which was as it is. Next, we start with the mid values. Okay, so but I will just write down here the values. Now, as you can see, I will explain how I have taken the values of D here once I write down the mid values. The mid value for first class is 2000 plus 3000 divided by 2, that is 2500. Then 3000 plus 4000 divided by 2, 3500. Respectively, I get all the mid values of the classes. Now, as you can see here, among all the mid value, which value is in the middle? Of all the values given here, the value which is in the middle is 5500. So what I am going to do, I am going to deduct 5500 as assumed mean from the D. From the previous tutorial, you must remember that whenever we are taking deviations, the method is x minus a divided by c. So x is our regular variable, that are the mid values. A assumed mean, I am taking the value which is in the middle, that is 5500, and the common factor, as you can see here, all of these values, if you can see, all of these values have a difference of 1000. Okay, so actually we can divide our common factor here. The class length is 1000 here, that's why I am taking 1000 as the common factor. So C is taken as 1000. So X minus A divided by C. Let's check out. First value here is 2500. So 2500 minus 5500 divided by 1000. When you solve it in your calci, you will get the answer negative 3. Similarly, 3500 minus 5500 divided by 1000, the answer in your calci will be negative 2. Similarly, we will get all the answers. Of course, 5500 minus 5500 is 0, so it will be 0. Then 1, 2, 3. Now, if class lengths are equal, you will usually get answer like this. The assumed mean will have 0 deviation. The values after it will have 1, 2, 3, and values before it will have negative 1, negative 2, negative 3 up to the value it has. So usually it happens, you will come to know it better once we do some other sums also. We don't need to make a total of this one. Next is the multiplication of frequency with the deviations. So number of workers will be multiplied by with the value of D here. That will get us negative 7, negative 6, negative 7, 0, 25, 32, and 36. Okay, just to make a total of the frequency multiplied by deviations, that is 74. I have given some explanation here that mid value is upper boundary point plus lower boundary point divided by 2. Assumed value, I have taken an observation from the middle part of the mid values, so to get the maximum ease of answering. And the class length, see, the common factor I have taken as the class length because the class lengths are equal. So in all the sums where class lengths are equal, take common factor as the class length itself, and you will see that it becomes very easy to do the calculation. You don't even need a calculator for that. We will start with the formula for mean. X bar is equal to A plus summation FIDI divided by summation FI multiplied by C. The A here is 5500, FIDI is 74, FI is 80, and common factor is 1000. So when you solve the latter part, that is 74 upon 80 into 1000, you get 925. And adding that into 5500, you get 6425. So the mean income of the workers working in a factory is 6425 rupees. Okay, let us do one more sum so we can understand it better naturally. The next illustration is illustration 8. The data about the weights in gram of mangoes from a tree are as follows. The minimum weight for these mangoes is 410 grams. Find the mean weight. Now the first table here which I am going to show you only depicts the data. Now the data is a bit different as the weight of mango is given as below 420, below 430, below 440, below 450, below 460, and below 170. Now it means that this is not a data given in classes, rather this is a data given as a cumulative frequency. Below 420 is included in below 430, below 430 is included in below 440. So the frequencies which are given here are the cumulative frequency, and that means we will convert this cumulative frequency into a regular classed distribution. Okay, so that's what we need to do. We will start with the conversion first. The weight of the mango will be converted into classes. Now the first class 420 and below, how much below? Then in the question itself it is given that the minimum weight for these mangoes is 410 grams. That means the first class will start from 410 grams and it will end at 420 grams. So the first class here will be 410 to 420. So naturally below 420 and below 430, that means the next class will be 420 to 430. Similarly 430 to 440, and so on up to 460 to 470, and then we need to make a total. Okay, now how to put the values here? The first below 420 frequency will be as it is, and for the remaining frequencies, if you go back to my second chapter, you will find a video on there. I have suggested it here on the top of your screen. In that video I have explained how to convert a cumulative frequency into a regular frequency. So using that method you can find out these frequencies here, and the total will be 180. So just check out that video and you will understand how to convert that. So once we have the original frequency distribution, the next table here will explain the mid values x, and again I have taken d here. I will explain it in a bit how I have taken the value of deviation. The mid value will be 410 to 420. The mid value is 415. The upper boundary plus lower boundary divided by 2. So similarly you will get all the mid values here. And now usually I take assumed mean from between the given values. Now there is not exact value in between, so I am taking 435 as the assumed mean here. And as you can see, the class length of all the classes is equal, and that equal class length is 10. So the common factor which I have taken is 10. Okay, so assumed mean is 435 and common factor is the class length, that is 10. So x minus 435 divided by 10. So 415 minus 435 divided by 10 will be negative 2, negative 1, 0, 1, 2, 3. As you can see, it goes continuously without any gaps because the class lengths are equal. Next, I multiply frequency with the deviation values. The frequencies are number of mangoes and the deviations are, I have written just here. So multiply them. You will get negative 28, negative 20, 0, 54, 70 and 45, and when you make a total it will be 121. So now let us start with the formula for writing down mean. X bar is equal to A plus summation Fi di divided by summation Fi multiplied by C. The assumed mean here is 435 plus 121 upon 180 into the common factor is 10. First solve the latter part. So 435 plus 6.722, and when you find the final answer it becomes 441 plus 72. So the statement here, thus the mean weight of mangoes is 441.72 grams. So when cumulative frequencies are given in the question, convert these cumulative frequencies into regular continuous frequency distribution and then calculate the mean value of the question. Final illustration for this particular tutorial, the distribution of annual sales tax of different companies in a zone is given below. Find the mean sales tax of these companies. Okay, so first of all we will check out the data here. The data sales tax in 1000 rupees and number of company, that will be F. So 0 to 10 in thousands it is, 10 to 20, 20 to 30, 30 to 50, 50 to 70 and total. Next 3, 14, 32, 40, 21 and the total is 110. Okay, now I will find out the mid values here, and then I will take out the D. I will explain how I have taken the D in a bit. The mid value is 5, 15, 25, 40, 60. Now as you can see in the classes are 0 to 10, 10 to 20, 20 to 30, and then they change from 30 to 50 and 50 to 70. That means the class lengths of each class is not similar. The first 3 classes have the class length 10, while the remaining 2 classes have the class length 20. That means I can't take 10 as a common factor here because the class lengths are not equal. So then I have to find another value which can be taken as a common factor. Now when you look at the values on your screen as the mid value, you can see that not all of them can be divided by 10, but each one of them can be divided by 5. So the common factor I have taken in this sum is 5. So C will be 5, and the middlemost value of the mid values is 25. So I have taken the assumed mean as 25. So x minus 25 upon 5 is my deviation value. So using that, that is for example, the first value 5 minus 25 divided by 5 will be negative 4. Similarly, negative 2, 0, 3 and 7. You just need to follow the method assumed mean as 25 and common factor as 5. Last, multiply the frequencies with the deviations and you will get your values. Be very cautious of using positive negative signs, because with that your answer change. Okay, so the total of the FD is 227 and total of the frequency is 110. We will put these values into our formula for mean. Regular formula we are using here. The assumed mean is 25. 227 upon 110 into common factor is 5. We will solve the latter part first, that is 25 plus 10.32, that is 35.32. But remember, this value is in thousands. Okay, so thus the mean sales tax paid by these companies is rupees 35.32 thousand. I hope you guys are getting what I am just explaining here. Let us check out a bit of a theory portion which is important for this topic and chapter. Advantages and disadvantages of mean. Here by mean I mean arithmetic mean. The advantages first, it is rigidly defined. Now whenever you are talking about advantages and disadvantages of any average, keep in mind the characteristics of an ideal average. So whichever characteristics of ideal average are applied to mean, that is advantage, and whichever cannot be applied to mean, those are the disadvantages. Simple. So it is rigidly defined, that's why it's an advantage. Then it is easy to understand and easy to calculate. It is based on all the observations. That's what I said before. Any measure which uses all the observations is the best measure. So it is based on all the observations. That's a good point. It is suitable for further algorithmic calculations. That means further calculations, further formulas can be used using the mean as the base on the data. So it is a good measure. It is comparatively more stable measure. I told in the characteristic of ideal measure that our average should be stable. Okay, so this measure is comparatively more stable. Comparatively means compared with the other measures. It is not absolutely stable, but comparatively, relatively, it is more stable. And the last, all the observations are given equal importance. It is very important point here that the observations are given equal importance. Each and every observation has same weight. Not a single observation is greater or bigger than the other observation. The disadvantages. The first one, affected by too large or too small observations. It is affected by too large or too small observations. If such observations are in the data, the answer is not accurate. It cannot be calculated for data with open-ended classes. Open-ended classes means the classes which does not have an end. As we know, we need a mid value for the class to calculate mean. Open-ended classes has no mid value. So in those cases, we cannot calculate mean. It cannot be found through graph or inspection. Just looking at the data or drawing a graph cannot give us an answer for the mean. We have to calculate the mean for that, which is kind of a letdown because it consumes a lot of time. If observations are missing, mean cannot be calculated. That means if some of the observations are not in the data, of course we cannot calculate mean. Before calculating mean, we need all of the data in front of us, then only we can calculate mean properly. If data is not evenly spread, mean is not a good measure. Evenly spread means when the data is spread on one side of it a lot and the other side is very less, then we cannot calculate mean for that. The data should be spread evenly, then only mean, the central value, can actually accurately give us the average answer. If observations have varying importance, that means the importance of observations keep on changing. Some observation has more importance, some observation has less importance. At that point of time, we cannot calculate mean. Let me give you an example. For example, wheat we eat more than the rice. Naturally, it is seen in maximum parts of India that wheat are eaten more than rice. So for us, wheat is more important, rice is less important, but mean doesn't take that into consideration. So whenever we are finding an average expenditure behind wheat and rice, it just takes an average of both rather than taking a weighted average of wheat and rice. So it cannot be used when the importance is different. So these were the advantages and disadvantages of the mean. Let us move forward to the last topic for the arithmetic mean. Some important results. I promise after this, in the next tutorial, I will start with the exercise. This is the last topic for the tutorial of arithmetic mean, illustrations, explanations, whatever. The first important result is that the sum of deviations of all observations of mean is always 0. Now if you don't know what I am writing down here, just look at the symbol here. Summation x minus x bar is always 0. Now you are familiar with the deviation. Okay, we deduct an assumed mean from the observations to get a smaller value. But what if we deduct the mean itself from all the observations and make a total of those remaining deviations? The answer will always be 0. Remember my point. Whenever we deduct the value of mean from all the given observations, the total remainder total of the remainder will always be 0. Now let me explain it symbolically. Actually it is not part of your syllabus, but I just felt like this is something extra which I should show you. So summation x minus x bar is there. Now you know how to open the bracket. Open the bracket, it means summation x minus summation x bar. Now summation x doesn't change, but summation x bar means x bar taken for the n number of times. So summation x minus n x bar will be there. Now just remember the formula for x bar, which is summation x divided by n. And what if I change the side of n on the opposite? It becomes n x bar is equal to summation x. What does this mean? This means that the value of n x bar and summation x is equal. And what happens when we deduct or subtract two equal values? The answer is 0. Okay, because nx bar and summation x always has equal values, their subtraction becomes 0. So ultimately it is a proof that summation x minus x bar is always 0. So the sum of deviations of all observation of mean is always 0. Remember this result. Even if you don't understand it right now, it is a very important result for the 12th standard, because this result will be used there, and not just in 12th but also in the college level. The second important result which I am going to show you here is that if all the values of variable x is multiplied with a constant b and a constant a is added to it, a new variable y is created. Now its relation with y means the relationship between variable x and y can be explained through a binomial equation of this. Yi is equal to a plus b xi. Xi is multiplied with b and a is added into it, so that we can get the variable y. Also remember this last line, that in case we have the value of x bar, we can put x bar in the place of xi and then we can calculate y bar. That means if we replace xi with x bar, yi will be replaced with y bar. So this is a kind of question which will be, this is a kind of result which will be used in 1 or 2 mark questions or MCQ type questions in the future. So keep both of these results in your mind for the future references. Welcome students to Vitan Sir's Unacant Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.